Alright, so here we go. Today what we're going to do is we're going to finish up our quadrilaterals, and we're going to finish up with parallelograms, rectangles, and trapezoids. So the first one I'm going to do is a trapezoid, and that's because I think it's the easiest one right now, and it's the one that requires the least amount of steps for today. So, trapezoid. Now when you're thinking about parallelograms, is the trapezoid in the parallelogram family? Is it a parallelogram? I'm hearing yes, I'm hearing no's. Why are you saying yes, Augustine? How many sides are parallel in a trapezoid? Looking at the figure. How many sides are parallel? There's two, right? Now, because there's only two sides that are parallel, it only has one pair of parallel sides. So it's actually not a parallelogram. Parallelograms have to have two pairs of parallel sides. Trapezoids, unfortunately, only have one pair. Now, here's the pair here. What do we call these two? What are they called? They're bases, yeah. And these are your legs. So our two bases are the two parallel sides. So for a trapezoid, all we have to do is prove that it has one pair of parallel sides. One pair of parallel sides. Now, with that being said, looking at our toolbox, are we going to use the distance formula, slope, or midpoint? Which one of them proves parallel, Sean?
Slope.
Slope? Yep, it's definitely slope. And since we're going to be using the slope formula, how many times do we think we're going to be doing it? How many sides are in a trapezoid? Four. So we're going to be doing it 4 times. Okay? Alright, let's do the parallelogram now. Parallelogram. Now, I am going to give you 3 different ways to prove something is a parallelogram, and after I give you those 3 ways, you only have to choose one of those ways you want to do it. Now, the thing is, just because you only have to choose one of those ways does not mean you don't want to memorize the other ones. You definitely want to memorize all 3 ways, because the way I've seen this asked as a multiple choice question is, if y'all remember from test questions, I'm pretty sure you've seen them before, the questions were, it's multiple choice, and the final answers are A, 1 only, B, 1 and 2. Like it has the Roman numerals, right? That's the way this is going to appear. So you're going to be tested, the way you're going to be tested is, they're going to list these 3 ways, plus a 4th way you can't use, and they're going to ask you either which of the following ways can prove that a shape is a parallelogram, or which of the following ways can you not use to prove a shape is a parallelogram. So you got to remember all 3 of them, but I'm going to give you today, I'm going to let you choose whichever one you want to do. So here are the 3 ways. You have to write them all down. The first way we can prove that something is a parallelogram is that it has 2 pairs of opposite parallel sides. 2 pair of opposite parallel sides. So this is parallel to that, and this must be parallel to that. That's one way. So again, looking at that, are we going to use distance, slope, or midpoint? Which one proves parallel? Slope. It's slope. And we're going to do slope 4 times again, because it's a 4-sided shape. So we're going to do slope formula 4 times. Okay, so that's one way you can prove a shape is a parallelogram. The second way you can prove a shape is a parallelogram is if it has 2 pairs of opposite congruent sides. Okay, so what do I mean by opposite congruent sides? I mean that this is congruent to that, and this is congruent to that. Now, if we're measuring the length of sides, are we going to use distance, slope, or midpoint? Distance. So we're going to do distance formula 4 times. Okay, last but not least, the third way you can possibly prove that a shape is a parallelogram is you can prove that the diagonals bisect each other. Okay, the diagonals bisect each other. Now, so far we've used slope, we used distance. This is the only one that we would use midpoint for. So we would do the midpoint. Now, the question is, how many times would we do the midpoint? 2. Because how many diagonals are there in a parallelogram? 2. So we're only going to do it twice. We're going to do it for this diagonal right here and this diagonal. Okay? Now, to prove that the diagonals bisect each other, in the end, they would have the same midpoint. Yeah, the same midpoint. So if you do the distance formula, if you do the midpoint formula for both of these, your final answer would be exactly the same because they have the same midpoint. Yes, Augustine?
So you can choose like whatever. Like you can choose the slope, distance, or midpoint.
Exactly. Now most students, they favor one right now. At this point they're like, oh, I like distance or I like slope or whatever. Whichever one you want to choose today, I'm letting you choose. Okay? Now, again, you have to remember the 3 ways though that you could possibly prove a parallelogram because it will appear as a multiple choice question. Okay? So you got to remember all 3 for test day. Alright, last but not least, we have our rectangle. Okay? Now, a rectangle is, it's a parallelogram, but it's a parallelogram that's standing straight up. And the reason it's standing straight up is because it has 4 right angles. Okay? So, we're going to have to use 2 formulas for the rectangle. We're going to have to use 2. The first one is, we're going to use the slope formula. And I'm going to write down we're going to use the slope formula. We're going to do it 4 times, but I'm going to explain to you why we're going to be using it. We're going to do the slope formula 4 times. Now here's why. When we perform the slope formula 4 times, what we're going to be proving is that not only are the opposite sides parallel to each other, but when we perform the slopes, this one should have the opposite reciprocal slope of this one, which means that there's a right angle here. So we're going to get 4 slopes, and with those 4 slopes, we're going to prove not only are the opposite sides parallel, but that they're also perpendicular to each other. Okay? So the first thing we're going to prove is that opposite sides are parallel and consecutive sides are perpendicular. And I'm going to write the perpendicular symbol since I'm running out of space. Perpendicular. So opposite sides are parallel, so that's parallel to that. This is parallel to that. And consecutive sides are perpendicular. So this is perpendicular to that. This is perpendicular to that. This is perpendicular to that. And this is perpendicular to that. The last thing we have to prove for a rectangle is that opposite sides are congruent. And the way we're going to do that, of course, if we're measuring the length of side, is going to be distance formula. We're going to do it 4 times. Yes, Augustine.
So you can choose slope or distance?
You have to do them both. So these 2, you must do both. And if you want to make a little side note of that, you can. These 2, you must do both. That's why I didn't number them. The reason I numbered these is because these are options. These 2 you have to do, which is why I put the bullets there. So you have to do this and that. Now you might think of this as the rectangle from yesterday. The square from yesterday. For a square, you have to do 2 things for it as well. So rectangles and square, you have to use 2 formulas for those. For all the other ones, it's only 1 formula. Okay? So let's go ahead and do our first proof. Now today, what you're going to notice is a little less structure in your notes. And the reason I'm putting less structure in them is because I'm going to give you more decisions and you more freedom to work these on your own without my help. So the first one, I'm going to give you about 2 minutes to go ahead and label this. So go ahead and take the next 2 minutes to label this. So go ahead and grab your straight edge. Begin plotting points for L, M, N, and O. And I'm going to give you 2 minutes to plot these points. Okay? And as you're applying them, I'm going to be applying them silently up here. Okay, now, as you're applying these, what I want you to do is I want you to double check and make sure that you're putting the points in the right place. I know that seems like a simple request, but you want to make sure that your model resembles the problem that you're performing to ensure that you get the full points on common assessment and free response questions. If your model is incorrect, you won't get those points. So make sure that you're accurately plotting these points. Okay? Alright, so what do we need to show? This is a parallelogram. So I'm going to give us a choice. Okay? I'm going to give us a vote. There's 3 ways. So look at the 3 ways you can prove something's a parallelogram. Okay? 1, 2, and 3. Raise your hand if you want to do it the first way. Raise your hand if you want to use that first formula to prove that it's a parallelogram. Okay, I got it 1. Raise your hand if you want to use the second formula to prove that it's a parallelogram. Alright, I got a few more. Raise your hand if you want to do it the third way. The third way. Okay? So I got the second way looks like it 1. The second way looks like it 1. Now here's the thing. If you were a number 1 or a number 2, if you wanted to use the first way or the second way, I'm going to give you the freedom right now to do it. So if you wanted to do number 1, do it. If you wanted to do number 3, do it. I'm going to do number 2 up here. So number 1 to number 3, go right ahead. Number 2, if you want to follow along with me, you can, but I'm going to do it in number 2 way. Now here's my hope in giving you the freedom. My hope is that all of us do it 3 different ways. Like one person does it the one way, one person does it the second way, one person does it the third way, and then I'm going to bring them and I'm going to show you the other ways as well. So go ahead and do it. Number 1, if you said number 1, if you raise your hand, do it. If you said number 3, do it. I'm going to do it number 2. So number 2 was, we're going to do the distance formula 4 times to prove that the opposite sides are congruent. Okay? So, what do we need to show? Yeah, opposite sides are congruent. And in order to show that, since we're doing distance, since we're finding the length of sides, we're going to use the distance formula. So the distance formula is the square root house, 2 sets of parentheses with a plus sign in between, a square attached to those parentheses. X's go in the first one and they're subtracted, Y's go in the second one and they're subtracted. Okay, so now my work. What I'm going to do is I'm going to prove that 2 pairs of sides are congruent. Okay, now the way I start, and you can do it several different ways, but you want to make sure that you list all 4 sides. So to keep myself ordered and to ensure that I list all 4 sides, the point to start at, and then I work my way around clockwise. So I'm going to start here, and I'm going to list side LM, then MN, then NO, then OL. Okay, since we're doing distance, I'm going to do the square root symbol or the rad house 4 times. Okay, I'm going to put my 2 sets of parentheses inside with a plus sign in between. Okay, I need to make sure I leave the squares right there. You don't want to forget to do those. It's a little thing that a lot of students forget. Make sure you're not that student. Okay, now I'll put the X's in the first ones and the Y's in the second one. So LM, X1, Y1, X2, Y2. Okay, so X2 4 minus negative 2. Y's 3 minus 3. Okay? Mn. Since my m is already labeled as x2 and y2, I'm going to label my n's as x1s and y1s. Okay? So x2, 4 minus x1, 2. y2, 3 minus y1, 2. No, since n is already labeled as x1 and y1, I'm going to label o's as x2s and y2s. So I get negative 4 minus 2, negative 2 minus negative 2. Okay, and last but not least, OL. Okay, O, notice that L is labeled as my 1s, O is already labeled as my 2s, so we're good to go. x2, negative 4 minus x1, negative 2. y2, negative 2 minus y1, 3. Okay? And so, calculator, going to grab my calculator so we can plug these in. Okay? And I should get the exact same number for all three of these. I'm sorry, not the exact same number. I should get the exact same number for two of them because we're trying to prove that two pairs of them are congruent. So two of them should have the same distance and the other two should have the same distance. So, square root, parentheses, 4 take away negative 2 squared plus 3 take away 3 squared. I got 6 for this one. Next one, square root symbol. Alright, square root symbol, parentheses, 4 take away 2 squared plus 3 take away negative 2 squared, and I got 5.385 units. In O, we got square root symbol, parentheses, negative 4 take away 2 squared plus parentheses, negative 2 take away negative 2 squared, and I get 6 for this one. Okay, and last but not least, square root house, parentheses, negative 4 take away negative 2 squared plus parentheses, negative 2 take away 3 squared, and I got 5.385. Okay, so again, our goal was to prove that two pairs of sides are congruent. The way we did that was we did the distance formula 4 times, and now we're going to write down what we just proved. We proved that because these two are the same, that side LM is congruent to side NO. We also proved that since these two are the same, that side MN is congruent to side OL. So because we proved that the opposite sides were in fact congruent, that LM was congruent to ON and LO was congruent to MN, that quadrilateral LMNO is a parallelogram because it has two pair of opposite congruent sides. Okay. Are there any 1s or 3s in here that did the other ways? Are y'all done? You had 3, Jennifer? Are you done? You finishing up right now? Are you done, Sean?
Yeah.
Which way?
3.
3? Can you come over here and bring it to me, please? So Sean did it the third way, and that way was he was going to use the midpoint formula to prove that the diagonals bisected each other. And you'll notice that with Sean's work, he did the two diagonals. So Sean, I'm going to draw the diagonals on your graph for you. Okay? Alright, now I drew them, and this point of intersection should be this point. So notice, when he did the midpoint formula for both of these, he found that both of the midpoint for LN was 0,5, and the midpoint for MO was 0,5. So since they had the exact same midpoint, that's where they intersect, which is about right here. So they do bisect each other, which means this is congruent to that, and this is congruent to that. So I'm going to finish this statement up for you. Quadrilateral LMNO is a parallelogram because the diagonals bisect each other. And then over here we did the statement, so I'm going to write down that the midpoint of LN is equal to the midpoint of MO. Okay, thank you, Sean. Did anybody do it the number one way? Anybody do it with and here, Sean, here's your homework from last night. Did anybody do it with the slope formula? Anybody do it? No? Everybody did it 2 or 3? Are you sure? You're literally making a face. Did you do it?
Yes.
The number one way?
No.
Oh, which way did you do it?
The one that you did.
Oh, the one that I did? Nobody did it number one way? Oh, okay. Alright, so let's do it the next one. We're going to prove a quadrilateral with vertices GHIJ is a rectangle. So, notice I didn't give you a sketch. Make sure on Common Assessment Day that if you're provided with a straight edge, that you use your straight edge to draw your sketch. So, the first thing you want to do is you want to draw an X and Y axis. Okay? And then you're going to plot these points, and you're going to estimate where. Alright? So the first one, G, is about at 1, 1. Okay, so I'm going to guess it goes about right there. H goes at 5, so this is 1, 2, 3, 4, about right here. 5, 3. Wait, this is 1. So 2, 3, so about right there. I is about 4, so this is 5, so it's 1, 2, 3, about right here. 4, and this is 3, 4, 5. That's about I. And then O is at 0, 3. I'm sorry, J is at 0, 3. Now once you do the estimate, grab your ruler again, line them up. Okay? Look about like that. Notice I'm a little off, it looks a little slanted right here, but that's totally fine. Remember, the point of this is just to have a model. Okay? So, going back to a rectangle, what is a rectangle? For a rectangle, we need to do the slope formula 4 times to prove that opposite sides are parallel and consecutive sides are perpendicular. And then we're going to do the distance formula for both sides, 4 times to prove that opposite sides are congruent. Alright? Now again, if you want to go on without me, please do it without me. You do not have to wait for me. Alright? So I'm going to continue doing it up here. I need to show 2 things. I need to show that opposite sides are parallel and consecutive sides are perpendicular. That's the first thing I need to show. The second thing I need to show is that the opposite sides are congruent. Okay? Now, to do this, I am going to use 2 formulas. The 2 formulas are slope, so y2 minus y1 over x2 minus x1. And again, we use slope formula to prove things are parallel or that things are perpendicular. And then the last one I'm going to do is distance formula. So x2 minus x1 squared plus y2 minus y1 squared. Alright? So, first one, I'm going to do the slope formula first. So I need to do the slope formula 4 times. So here's my work. Okay, so JI should be parallel to GH, and JG should be parallel to IH. Okay, so let's do the slope with those. First one, JI, x1, y1, x2, y2. So the y's on top, numerator, denominator are going to be your x's. So 3 minus 5, 0 minus 4. I get negative 2 here, I get negative 4 here. A negative divided by a negative gives me a positive 2/4, which is equal to 1/2. Okay. Next one, GH, x1, y1, x2, y2. I get 3 minus 1 over 5 minus 1. 3 minus 1 is 2, 5 minus 1 is 4, which is 1/2. And these two are definitely parallel because they have the same slope. So JI is parallel to GH. That's what we just proved. Okay. Next thing, JG. So let's look at G. It's right here. Notice that they're already labeled as x1s and x2s, so I'm just going to use it as is. So y2, 3 minus 1 over 0 minus 1. 3 minus 2 is 2. 0 minus 1 is 1. Did I mess up somewhere?
Negative 1.
Negative 1? There we go. Thank you. 2 divided by negative 1 would be negative 2. Alright, IH. Notice they're already labeled, so I'm going to use them as is. Y2, 3 minus y1, 5 over 5 minus 4. 3 minus 5 is negative 2. 5 minus 4 is 1, and that is negative 2. Alright, now since these two have the same slopes, they are also parallel, so JG is parallel to IH. Okay? So again, because they have the same slope, because they have the same M, they are parallel. Now, notice, 1/2 and negative 2, are they opposite reciprocals? Yes or no? Yeah, so since they're opposite reciprocals, that means they're what? Perpendicular. Yeah, they're perpendicular. So opposite reciprocals means they're perpendicular. So we have also proven that JI, look at our picture, JI is perpendicular to GH because they have opposite reciprocal slopes, GH. Wait, did I write that down? No, JG. Sorry about that. So JI is perpendicular to JG. So we can put our right angle here because they have opposite reciprocal slopes. JI is perpendicular to JG. We've also proven that these two, since they have opposite reciprocal slopes, since GH is 1/2 and IH is negative 2, they two are perpendicular. So GH, IH. Oh, so we can go ahead and do that with the rest, but I'm not going to. So the ones that have the same slopes are perpendicular. The ones that have opposite reciprocal slopes are, same slopes are parallel. Opposite reciprocal slopes are perpendicular. Any questions on that one? Alright, last thing we have to do is we're going to do the distance formula 4 times to prove that the opposite sides are congruent. So we're going to try to prove that JI is congruent to GH and JG is congruent to IH. Okay? So I'm going to do a distance formula 4 times. So 1, 2, 3, 4. Okay, JI, we have (0 minus 4 squared plus 3 minus 5 squared. GH, we have 5 minus 1 squared plus 3 minus 1 squared. JG, we have 0 minus 1 squared plus 3 minus 1 squared. And then for IH, we have 5 minus 4 squared plus 3 minus 5 squared. Okay? Has anybody plugged those in already?
Yeah.
Yeah? Esther, what'd you get?
For GH, I got 4.472.
Okay.
And for HI, I got 2.236.
2.236?
And for IJ, I got 4.472.
Okay.
And for JG, I got 2.236.
Perfect. So notice, 2 of them are the same. These two have the same measure, so they're the same length. So JG is congruent to IH because they have the same number. And JI is congruent to GH because they too have the same number. So quadrilateral GHIJ is a rectangle because opposite sides are parallel and congruent, and consecutive sides are perpendicular. So now, again, opposite sides are parallel and congruent. Consecutive sides are perpendicular. Alright, last one, trapezoid. This one should be faster than the other one. So we're going to show, since it's a trapezoid, that it only has one pair of parallel sides. And the way we're going to do that is we are going to use the slope formula, which is y2 minus y1 over x2 minus x1. So I'm going to go ahead and quickly graph these because we're running out of time. We have K, A, T, and E. Okay? Now you're going to notice that side KE, notice how it just stays on the y-axis. It doesn't pass the vertical line test, so that the slope you should get for KE is going to be undefined because it doesn't pass the vertical line test. So expect that to happen when you're doing the slope for that one. So KA, AT, ET, and KE. I'm going to do the slope for those four. So KA, x1, y1, x2, y2. I get 6 minus 4 over 3 minus 0. 6 minus 4 is 2. 3 minus 0 is 3. So that's the slope for that one. AT, x1, y1. I get 6 minus 2 over 3 minus 6. 6 minus 2 is 4. 3 minus 6 is negative 3. So negative 4/3. Next one, ET. I got x2, y2, negative 2 minus 2, and then I get 0 minus 6. These two is going to give me negative 2 minus 2 is negative 4. 0 minus 6 is negative 6, which is negative times a negative is a negative divided by a negative is a positive. So positive 4/6, which is positive 2/3. And then last but not least, we have KE. KE is y2, negative 2 minus 4 over 0 minus 0, and that's the one that's going to be undefined. Okay? So because these two have the same slope, they are parallel, and we have proven that it has one pair of parallel sides.